basically what we're going to do first, from now on, we're going to kind of be focusing mainly on Nuke for the rest of the day. We'll be talking about what passes we need to export to kind of rebuild our RGB and what the concept of that means. And we're going to be going through lots of different scene setups that we created for Jonah. So first of all, let's just have a look at the Nuke interface, and then we'll figure out how we bring things in. So Nuke operates in 3 separate windows, and everyone has a different kind of preference on how these windows are set up. Default will open like this. Most people have kind of multiple monitors, and I like to undock my node graph and dock it into, if I just undock this, I like to kind of dock my node graph into a separate screen, and then I have my kind of viewer in a different screen as well, basically. Let's just reset. Let's just close Nuke down and reset to get it back to the default. Because if you don't have 2 screens active, you won't be able to move those windows onto a different screen. So this is the default. So we have 3 separate windows. We have our node tree area, we have our viewer area, and we have our kind of properties panel, basically. And then all of our tools are kind of accessible from this kind of Photoshop replicating kind of option here, basically. So everything we can access from here. But you'd be surprised actually that the more you use Nuke, the less you'll actually use this this kind of toolbar option here, because you'll activate everything through tab. And basically tab is similar, if you use AutoCAD or anything like that, it's a similar kind of concept where you can kind of like open up a menu and then just type in whatever command you might want, and then just press enter, and that node will then appear. And you can do that within the menus here. Everything will be found here, but to be honest, this is alien to me. I wouldn't know how to use this, because I use everything through this tab option here, and then I just type in what I want. And once you've used Nuke a couple of times, you'll notice that you'll use the same nodes again and again and again, and it becomes very second nature just to type in what node you want. And it's very intuitive as well. If you don't have to kind of know what's there. You can kind of while you're testing, you can kind of guess. You know, oh, can it do a glow? You type in glow, yeah, it can. It's got a glow. You know, what else can it do? You can just kind of play and see what it might have, and also look through the menus and understand what's available at your disposal, because there's literally thousands of nodes within Nuke. Now, all these options at the top are basically there to display the RGB, the alpha, and you can kind of make your viewport display different settings within your scene. If you want to see what an alpha is doing on a particular node, you can check it here. If you want to just view the RGB, you can change all these you can look at all the different parameters here. You can even change the exposure of your kind of scene, just to see what the kind of values are doing. The one of the really powerful things about Nuke is that it's full float 32-bit from start to finish. There's no degradation at all when you're working. So that means that we can keep our comp in full color space right at the end. It's not like in Photoshop where you bring in an EXR and you immediately have to change it to 16-bit to actually use any of the functions of Photoshop. All the functions in Nuke are 32-bit native, so you don't ever have to flatten anything. So in our properties panel, you can see this number 10. That'll mean that we can display 10 different bars here. By default, this can get pretty confusing pretty quickly, so I just by default change this to 1. We have our timeline here, which shows us our kind of frame range, and we can press play and do all sorts of different things. We can change our frame rate. One thing we want to do, which we can do at any stage, it doesn't really matter if we do this before, during, or kind of at the end of our project, we want to press S and go to our system settings. S will load our FPS, which we want to change to the UK25 in my case. Also the default file format, which has defaults here as HD, for example. We've rendered out a HD image to just test here. So we can see we have a kind of HD setting here. Again, this can change at any point, and by default, when you bring in footage or clips or renders, when you look at it through the viewer, it will kind of snap to whatever format your input is. But it's good to have your settings, what you want as well, to keep things consistent. So let's kind of see what, let's just quickly cancel this. Or actually, no, what we'll do is we'll open up a new file, because I want to render that later on to kind of illustrate something else. But we've already got a pre-render of something where we can kind of rebuild our RGB. And what I want to do is kind of explain what passes we need to actually rebuild our RGB and what passes we need or we want to kind of play around with everything else. So while that's loading, if I just if I bring in the kind of renders the render I've just rendered out, I've rendered out a still. I'm going to illustrate a lot of the concepts first with a still, and then we can look at some animation later on. So again, you can access things by tab. You can also access other assets by right-clicking, and then you can actually see slightly more easily what's in all these menus, rather than having to click and look at all of these things here. So there's tab, but there's also right-click. So File, Edit, Render, Image, Draw, and so on. Now to bring in any footage, you go to Image Read. So that then brings up our document where we can kind of locate our renders. So if we look for our render here, now these are static images, but what another great thing that Nuke does is if this was an animation, it would read it as 0 to 100, say, and it wouldn't read it like After Effects does as a kind of massive long image sequence which you have to pick the first frame. It will just read it as one file, and then you can just click and drag everything. So even if this was like a 1,000 frame animation with all these passes, it would still display it in exactly the same way that I'm looking at it now. So so it reads it as one kind of movie file, or one kind of sequence file, rather than a whole list of thousands of frames, which is really good. So if you press open, it's going to bring in all of our kind of assets here, right? Thing to remember, when you're in any of these nodes, any of these windows, spacebar goes full screen. So we can now look at our viewer full screen and review things. We can go back out our spacebar, and we can also work in our node tree in full screen while we're kind of editing and we don't need to see our viewer. I guess you do this less when you're working in multi-screen because you've automatically given yourself a lot more space to work with. But if you're working on a single screen, then that becomes really useful to actually work with, because you want this node space to be really big, because this is where you'll be working most of your time. You'll be working in this node space. I'll go in there for now, and we'll just look at some of the passes which we need to export. Other thing, it kind of gets a bit messy sometimes when you're kind of moving all this stuff around in your node tree. So one of the things you do first when you bring in your read nodes is just press L, and that will essentially kind of straighten up all of your nodes. So let's have a look at what we've got here. So if we click our spacebar again, we just look at our nodes here. Important thing to notice, we've got our viewer here, which is always there. We can delete him, and what happens if we delete him? We lose our viewer. So we need to press Tab, Viewer, and activate our viewer again. So that puts our viewer back in here, and that just is our display. And we can have multiple viewers, multiple windows. We can do all sorts of things in here. We can have split screen. We can do all sorts of things. But the concept of this viewer is if you press 1 on a node, it's going to display that node, right? Good thing you can do is you can press 1, 2, 3, 4, and so on. And you can actually just very quickly flick through different things, which becomes really useful when kind of comparing different options, or just having different feeds on different numbers, kind of shortcuts. And you can manually undock them and kind of access again. So let's just look at this. What we'll do is we'll look at our RGB. So we'll put our RGB over here. So that's our raw render, that's our RGB. Now, more often than not, you don't actually use this guy in Nuke, which is quite interesting. You kind of rebuild him using the other passes. And there's some passes that are that you render out for rebuilding, and there's some passes you render out just for effect or color grading or masks. So let's just go in and isolate our masks. So we have our alpha, and with this file we haven't got our sky separated out. We're rendering that out now, but I'll show you the differences between those two things in two different files. Let's just move our kind of passes we'll use for editing there. So basically, there's a few passes you need to rebuild your RGB. You need global illumination, so we'll put him over there. You need your Vray reflection, your Vray refraction, self-illumination if you've got self-illuminated objects, so it's just being aware of what you've got in your scene, specular, lighting, and background if you have a separate background in your scene that isn't part of your lighting setup. Okay, so at the moment, if we go back into our kind of viewer mode, at the moment these are very separate passes. You know, we can see our global illumination separately, our reflection, refraction, our self-illumination. We've got our dome visible, so we have that rendered in as well as our kind of little light here. We've got our specular, but we don't have any specularity. So it wouldn't in this particular scene, it wouldn't actually be a problem if we didn't include this, but it's good practice to include the ones that you need anyway. And then our Vray lighting, right? So the way that we merge these together is using the merge node. So yeah, Nuke is pretty logical. And then if you double click this node, you won't be able to see anything because you're in you're just in your node graph here. But if you double click him, you'll get options within the properties, and that's where you can kind of change the parameters of what this object's doing. Likewise, if you double click on any of your nodes, it will kind of bring up options for that, where it's saved, the frame range, you can alter that, and all sorts of other options that you have here. So if we could double click on our merge node again, if we had this on the default 10, what would happen is this would quickly fill up, and it would get a bit confusing, and we'd have to kind of scroll down and all sorts of things. So I'll keep this on 1, just for organization's sake, and just double click on the node that I want to see the options for. So the default merge setting is merge over. What you want to do is change that to merge plus. And these are often called your plus files, or your plus passes. That's what it's often referred to in visual effects. So the way that you kind of use Nuke is that everything works with the kind of B channel pointing up and the A channel pointing us to the side. Now here we haven't really got a background. That's not really got anything there. But just as a work of practice, I always put my background on the top here, and then I kind of plus in all of my other read nodes on the side. So what I'll do is now we've set him to plus, I'll copy him and paste him down, and I'll just keep attaching this chain, and then I'll just see what that's doing. So here I've added my global illumination and my reflection. So these are separate now. These are separate passes. So now if I copy that and paste them again, B and A, I've now added my refraction. Copy again. Self-illumination. I've now added my self-illumination. So let's just go down and build the other two passes here. There's nothing on the specularity, but we'll leave it in there anyway, just in case we want to re-render, and then we do change those materials. So when we go to the bottom there, we press 1 on our viewer. So here's our viewer. So we have our rebuilt RGB and our RGB, and let's just check that they're the same. So we press 1 on that, 2 on that, and they're the same, right? So now we've successfully rebuilt RGB with all of these different passes, and it should be obvious why we do this, because now we have an immense amount of control over everything to do with our render. So there's lots of different things we can do here, right? So the first thing we want to take note is a few more settings within the merge node. When you create complicated compositions, you might be using footages of different sizes, rescaling things, like you use different nodes called reformat to kind of change the size of different things. You might be comping in a different background, which is a different size. So the kind of bounding box for all of this data can get quite large. So you want to set the bounding box to B, which always then reads through your B channel and will read whatever is at the top of your setting here, which is in this case, your 1920 footage. And this becomes a bit more important later on, but it's just an important thing to kind of get used to doing early, is setting your bounding box to your main format. Because otherwise it's going to create a union by default of all of your elements together. In this case, all of these are the same size, so it makes no difference. But I'm just saying, watch out for that, because it can really change the speed of your scene when working with really heavy files, and just be aware of what it does. We have lots of different options here within our merge node. We can mask it, so we can kind of say, okay, actually we don't want the reflection on these balls here. We're gonna mask it there, or we're gonna mask any of the kind of elements using manual roto, or we can kind of mask using any of the kind of channels that we export. There's a mix amount. So if you double click on our reflection, we can kind of change the mix of that. So we can kind of alter how that's working on the whole scene. Now, there's a temptation to just alter the mix amount of everything, but there's a slightly more dynamic way of controlling the intensity and the amount of your passes in between the merge node and your read node. So if we just click on the tab and we go to multiply math, and what this is, if we plonk him in there, and what we have there, if we just kind of copy that node again, if you just drag a node onto a line, it will automatically give you the option to kind of insert that into anywhere, right? So if we double click on our multiply, on our global illumination, for example, what we've now got is a value parameter of 1, but we can go minus or plus, which is a hugely powerful thing to be able to do. We can kind of take away global illumination from our scene, and we can add global illumination to our scene, right? So by default, I tend to kind of have these within all of my read nodes here, just to give me the flexibility of being able to tweak each one. So, for example, reflection. Let's take the reflection. Let's increase that reflection, or decrease the reflection. It's just a much more dynamic way rather than just an opacity change. You're actually changing the value of that contribution to the RGB. Likewise with your refraction and your specularity, self-illumination. Let's just make our viewer slightly smaller. So you can see the power of rebuilding the RGB and exactly what it does. So we can have our multiply values there. What we can also then do is really go in and tweak things. I mean, everything again is very self-explanatory in Nuke. So tab, press the grade node, and you've then got a grade node to actually edit some settings of this reflection separate. So it's not like when you're selecting the glass or you're selecting things manually through mats, and then you're kind of altering colors of things. You're actually changing fundamentally the assets that rebuild this scene. So we can then change this reflection, and we can add, if we go into our gamma and click on this wheel, again, just play around with the kind of grade node. There's lots of different settings, and you can see just the amount of color depth that Nuke has at default is 32-bit. So we can really, play around with the kind of depth, and they kind of have a super amount of control over the kind of levels of our image. Let's just focus on the reflection here. Let's go to the gamma. If I'm kind of altering the overall color of something, I always change it in the gamma here by checking the wheel, and then I can overall change the color of things separate, and it's going to change naturally the reflection of this in all of my assets of my scene. So it's not like changing the color of that and then having the problem of changing the color of that within there. it's changing the color of everything simultaneously, and that gives us a huge amount of control over our image. So we can keep messing around with all of these different things to kind of rebuild. We can change the refraction. We can use a color correct, and it's just getting used to which nodes do what. And this has a master saturation for shadows, midtones, and highlights. It's very powerful. You can go to your ranges and you can tweak the curves. There's all sorts of different nodes that do different things. Another one is a hue correct, and that gives us our some different curve levels for saturation, luminance, red, green, blue, lots of different color control. The color control within Nuke is one of the best features of it, basically, and you have an immense amount of control over very specific settings within your scene. The other great feature within self-illumination, in between the self-illumination and the image, you can add a glow. The worst thing about glow and lots of other applications is that it applies it to everything in our scene, you know. Whereas this, you can be really specific. Let's just do a save. You can be really specific about what you're attaching these kind of effects to. If we just let Nuke come back to us here. Okay, so what we've now done here is we've added glow to our self-illumination channel. And it's doing it to our sky as well, which we might want to have. However, normally we'd want the sky on a separate pass, which would be on our background, right? So we'd be able to glow that separately or change that separately, and then the glow for the self-illumination would only be affecting our little box here. And we're rendering that out now, so it's separate. So we can test that later. But for this test, you get the idea. We have a self-illumination, which would normally just be this box, and we can glow him separately. So we're not picking apart any of the highlights, and we're not kind of glowing anything that we don't want to glow. We have a large amount of control over what we're doing. One of the other really important features to know as soon as you start Nuke is Deactivates Node. So you can instantly see what it's doing. And you can deactivate the entire pass. And it does it for everything, and it puts a little box on everything, basically. What I really like about Nuke, the main thing, is its overall a node-based layout. And this, unlike After Effects or Photoshop or other layer-based systems, you get to see everything. It's like taking your After Effects file with all those compositions within compositions and compositions and compositions and compositions, and literally splaying it out on a big table so you can see everything. And that's the main big change. For me, was kind of realizing that and being able to actually go in and see what I'm doing, and anyone can go in and see how you've rebuilt something. And then it's just about being organized and layering everything properly. Another good feature is that once you select all your nodes, press tab, you press backdrop or back, and it'll, then it will kind of organize it in this little guy here, and you can then move him around separately. And then if you go out of full screen mode and double click this backdrop, you can then add a label and call it Rgb rebuild, say. And we can change the size of that to be a bit more visible for whoever's coming into the scene next. So you can see, right, with our RGBs over here, and we normally keep him close so we can always compare and sometimes use him. We don't always rebuild the RGB. It really depends. Really depends on the scene. It depends if our RGB is good enough. It depends if we want to go in and tweak all this stuff in here, right? We might not need to. And the difference is the heaviness of the scene. Nuke loading this is much more difficult than nuke loading this, right? Because we've got 1, 2, 3, 4, 5, 6, 7 passes there, and this is just one, and they're all at full HD. And if it's an animation, that's a considerable amount more frames that Nuke has to load. And it's just, there's different ways of combating that. What you can do is, the only reason really why you might want to do that is if sometimes you do build really complicated trees, and it's not so much the viewer being slow, because the viewer sometimes is a bit slow, but that's not one of the biggest problems. The biggest problems would be the export time. So when you try and export this out, what is the kind of way of dealing with this is if you, once you've made your adjustment and you're happy with everything here, you don't have to do this straight away, but when you notice your scene getting heavy or your render times kind of taking a long time, if we just press tab and right and create a right node, and we plug that in to our tree there, we put him on the side for now because he's not going to be, we always work down in Nuke, it's kind of top down, but we put him on the side because this is kind of like an intermediate export. We click on our right node and we can kind of write this guy out and then plug in the rendered output of that back into our tree. And we can do that again and again. It doesn't mean we can't go and export this. It just means that we can kind of have this here, and then underneath it we can have a little node we rebring in, which is an export of all this data, and we can kind of label it such, RGB rebuild, flat, or whatever we want to do to kind of rename and organize our files. And I'll show you some of our templates that we use, where we kind of have a really anal system to kind of keep our folders really organized. But essentially, that's a way of kind of exporting out a part of your scene which you're happy with, and then if we just do that now as an example, so in our right node we can see we've got our file. So let's just select where we want to save this guy. We'll save him in the raw Nuke folder here. We'll call him CG School Test 1 Rgb Exports, and then we'll put a dot, and then what we'll do is we'll put a hash or 333 hash dot exr. Let's not compress any of this. When you're working like this, you don't want to export a JPEG and bring that back in because you've lost all your color depth. So let's save them out as an image here. You got lots of settings here to change the aspect of this. We rendered out a 16-bit half float from Max, but that is 32-bit. Make no mistake. The 32-bit float is a super uncompressed file format that uses no compression, and you still have the 32-bit color depth when you render out a 16-bit half float. Don't feel like you have to create 32-bit float renders from Max, because you will be waiting all day for those to load in any program. They will be humongous files, and you'll fill up your server very quickly. So there's no reason ever to export a 32-bit float from Nuke, and I'll argue with anyone who disagrees with me. Just because the file formats are like quadruple the size. It's like in the Rise of the Planet of the Apes. They rendered out 32-bit float full EXR2s with the depth pass, the new depth pass, which is a kind of feature of some of the more advanced rendering engines, as well as a new feature within Nuke where you can kind of, essentially each image has a kind of point position data. So they're very, very heavy EXR files, and I think each one is something like several gigabytes for each render, basically, which is a workflow that they tried out. But there's a great making of they have on the Rise of the Planet of the Apes, which talks about the use of EXR2 within Nuke, which is going to be hopefully be a great feature within Vray 3. But anyway, that's a bit more advanced than even some of the stuff we've been playing around with. So let's write him out. So we go to render, only input frame 1, continue. We've rendered him out. So now let's right click and read. Let's find him. Where are we? Nuke. Testing, no, export. So let's bring him back in. And now we've brought him in as a separate EXR. So if we press 1 on him, 2 on him, they're exactly the same. But loading this guy within the scene is good. Is much lighter on the scene. Don't feel like you have to do this step kind of like all the time or straight away like I've done here. I've just illustrated, I've illustrated it at this point because it's good to notice, but it's good to just keep building your tree and building your file and then just see where you think needs exporting. Because you might want to play around with this for a lot longer than what I've just done here. You kind of want this bit separate so it's more obvious. So what you can do is, let's just bring him down here. A great feature as well, if you press Control, you'll notice these little dots appearing in between all of my lines. And then if I click one of those dots, I've created a dot so I can then separate my scene out here, right? So then I can kind of select these guys here, select my backdrop, double click on my backdrop, call this, Rgb Export. And now it's really obvious what I've done. I've got my rebuild here, I've got my Rgb export here, and I've got my write node and my read node that comes back in here. And then if we just put, also you don't have to, if you want a dot somewhere else and you don't want to have to do that and detach it, you can just press the dot button and it'll give you a dot. So now we can continue our tree from our kind of export here, continuing going down. So let's just see our render has finished that we were looking at before. So I am going to quickly replace some of these nodes, and then I'm going to talk about if I import these other 2 nodes that I want to, because I want to separate out my self-illumination and my background to be able to control that glow separately. I'll just swap out those nodes now. So static scene B, I want to have my self-illumination and my background. Open them in. Let's just swap out my background here and my self-illumination here. And then you can see now I've got this as a separate element to my background, which is nice because I can add my glow separately to my objects now, and I can add my separate color correction or glows or anything I might want to do to my background. So I might want it glowing, but I might not want it blowing out. So I might want to kind of add a glow, turn the brightness down a little bit, turn up the size to get more bleed. Then I might want to also add a grade node and kind of take down the white point of that glow. So I keep my detail of my map, but I've effectively created this diffuse layer around it. So you can see exactly what that's doing there. I've kind of got full control of my reflection, my self-illumination, my background environment, and this is way more powerful than just adding kind of glows and effects and having complicated roto channels to kind of mask certain areas from not blowing out or things like that. Before I move on, were there any questions at this stage about Nuke? I always do this when Jeff leaves the room, so I should stop doing that really. Hang on 1 second, I'll... okay. Does the channel order matter? Does the channel what, sorry?
Yeah, does the order of the channels and the merging stack as you rebuild it
No,
matter?
it's a good question. The order that these are in, the global illumination could be here, self-illumination could be there. It makes no difference to the order of these things. As a rule of practice, I always like having the background at the top. It's just a visual thing. I guess it just makes sense for me. But then it makes no difference what order you rebuild this stuff in, basically. Was there any other questions in the room? I'll wait till Jeff comes back in to answer if there's any online questions. But just for now, is there any more questions in the room about what we've done so far in Nuke? You can do that. You can render out your separate EXRs, and different studios do that. And you can extract the there's different ways that you can kind of extract your EXRs, your channels of your EXR through different elements here. And these, if you do that, then you will see a different list here with different options that you can kind of extract. And you can extract those different things in other ways. The reason why we don't do this, because I played with, when I first started learning Nuke, I looked at lots of different workflows and options that we created. And then I had a conversation with one of the lead compositors at MPC, and they said that they export all of their render passes separately because it gives them a lot more control, and they find that the baking everything into one EXR workflow often kind of crashes both Max and Nuke, and there's lots more problem solving that they've had to do. It's a lot kind of more effort as well, separating all the channels in composite, especially if you just want to kind of get in and start going with an RGB separate, or if you want to rebuild your passes. It's just a workflow that they have adopted more, and something that we got taught by them basically. So you can do both, but this is the workflow that I'm teaching, and this is the workflow that I find more comfortable with basically. I like having my passes all saved out separately, and I like choosing which ones to pick in, because you might not want to bring in all your passes, and if you bake out a whole heap of passes into one file, you're then stuck with that in the file, and you have to extract everything. It makes the file a lot heavier basically. So keeping everything separate allows you to have much more control over what you're bringing in and what you're using basically. He was referring to the option within Max of saving out the baking in all of the channels within one EXR, which you can do for comping in Photoshop as well, but again, it's not something I recommend personally. Yeah, we've lost Jeff, so we'll see if there's any online questions in a second. But I want to introduce you to another concept here before we go any further with building our scene. Okay, we have all of our other passes that we haven't used yet for different purposes. Now, if we want to, say later down this line, we want to do multiple color corrections using multiple masks, and we'll have to kind of copy our read nodes around. So we want to do a correction over here, but then like later on, we also want to do a kind of correction, and we have a tree that's kind of building, getting more complicated. If we then re-render this file and save it out separately as a different name from Max, then we have to go through all of these read nodes, and we have to kind of go and replace everything manually, and it can take a long time. But then you have to do it again over here, because these are not instanced nodes. These are just pure read nodes, separate read nodes. It will take a long time to go through the file and kind of like update everything, especially if you've got multiple. You'll see in some of the other files that we've created multiple scene setups. And this is actually a relatively new thing which we've started doing. So some of the comps I'm going to be showing you don't actually have this in yet. But essentially what we've started to do is, if we detach all of our guys and put them up here, we've started to treat all of our read nodes at the top of our comps. So we can see all of the read nodes and we know what's going on, right? Then what we do is we create a postage stamp. And what the postage stamp is, it's just a clone of that read node. So you can see what it's doing there. It's kind of cloning that read node. Again, this is something we've only adopted in the last couple of projects. So it wasn't quite there for when we were doing Jonah. But now we can kind of label this node and call him, the same name as what our read node is, multi-mat 1 or whatever. And we can say that it's now called multi-mat 1, so we know what it is. But we also want to do another thing. What we don't want is to use these nodes and have these lines crossing everywhere within our comp. We want to know what it's referencing, but we don't want to have these lines crisscrossing everywhere. It's going to make things very messy. So we want to double click. We just want to put hide input. So when we unclick it, we've got a nice clean comp. When we click it, we can see exactly where that postage stamp's going. So we want to create one of these for all of all of our things. So if we just paste a few of these in, then we can just quickly link them up with our read nodes. There is one disadvantage or thing to note when you do these, though, is that, which should really be fixed, is that if you then copy these nodes, these Postage Stamps nodes, it loses its link. So you have to then, every time you copy it, you have to relink it to the main Rgb, the main read node that you're linking it to, which is a small sacrifice for being able to have instances of our read node all around our model. So these are two instances. So then if we had to relink any of these things or change any of them, we can just relink this guy in here, and then it will relink all the instances of that postage stamp automatically. And that's really good, especially for the multi-mats, which we want to use several times. Because there are ways of kind of like, we used to try and cheat with the multi-mats. So if you're using it as a mask somewhere, but you also want to use it over here or somewhere, over here, then you could just create a complex tree that kind of goes everywhere and does the same thing, but it can again be quite messy. Sometimes it's just nicer to have instances of things. In this case, it's fine because this is quite a contained little thing. But if you want to kind of have a node which is much, much further away, linking to the same thing, you're inevitably just going to copy that read node, and then you don't have an instance. This way, you have a postage stamp instance of your read node. You can copy him and clone him wherever you want. Okay. Yeah, let me just, I can't check if there's any questions online at the moment, but again, we'll just wait for Jeff to come back to address anyone's concerns online. But so this is basically how we set up our scenes. We have all of our clones, which we can then use. So we'll rebuild our Rgb back here. It's called, we won't worry about the naming. If we had more time, we would change all of these to the name what we want. We know this is the Rgb color, so we can plonk him on the side here. We know this is the background. What I tend to do also is just make sure that I'm using the right ones. This is our Rgb lighting, specular, self-illumination, our refraction, and our reflection. So we had these in slightly different orders before, but that doesn't really matter, we haven't changed much. And again, we can just easily deactivate a whole bunch of stuff there. If you press X on a node like this, it will deactivate the whole thing, which is sometimes very useful. So also, when you've highlighted all of your elements, you can see exactly where everything's linking to. That becomes really good because when you want to bring in a new set of new renders, for example, you can kind of bring in your new set. Let's just, for the sake of argument, say that this is your new set that you brought in. You've updated things. You can just select everything in your scene, and then very quickly just update your scene with the latest assets. What we tend to do, which I'll explain more later on, especially for our kind of ArcViz image workflow, is that when we're in the development of a project, we kind of have a working folder, a current folder, and then we save all of our latest renders into that, and we overwrite. But then we copy that current folder and we date it when we do that. So we've always got a record of our kind of what we've done. But then we can have a current folder which is always linked in our Nuke comp, and then which is automatically updating every time we re-render. And then we have a comp which is automatically updating with all of our passes and things like that. And we'll go through that example slightly later on. So this is kind of our basic kind of setup for rebuilding our RGB. Now, I want to talk about how we use the passes and masks and the shuffling out the different channels. So we've got our RGB export here. Let's just work with that for now. Or actually, let's update where we were at before, because we changed our background slightly, which we were slightly more happy with. So let's export where we're at there. Again, render him out. So this guy, we do the same thing with this guy. We would put him with our read nodes. We might want to organize this and name things slightly differently in different background nodes. We've got our export here, got our postage stamp, and then we are, if that's going to update, hang on 1 second. Let's have a look what we've got here. Delete him, do a new postage stamp. Not too sure why he didn't want to do that. Okay, what we've done, if you just go to there, we export that again. Let's just have a look at updating this guy, reload. There we go. We needed to reload him because we'd automatically overwrit and we didn't update the read node. So this postage stamp, again, we want all of our kind of, anything we're reading into the file to be up the top. And then we create our new postage stamp, hide the input, and then he's our new exported guy here. So let's continue with this tree down and let's look at some color correction. Go in full screen mode while we're working, while we don't need to see the viewer. Let's start using some of these. Again, these are clones of our read nodes. We don't want to use these. We want to use our postage stamps. So let's take our two color correction guys here. Copy him, which is fine. You can clone that, which is, it works, but it's just not good practice, basically. You can clone from a postage stamp, but we tend not to try and do that. So let's increase our tree here. Let's click on our postage stamp. Let's click on our grade node. Let's bring this in here. Then we'll attach automatically, all the time these arrows are on the side of nodes, on the right-hand side, are always masks. So that arrow will always be a mask, no matter what node you're looking at. And you can mask almost every node with whatever you want. If we look at this now, we can see that we've got a grade node. Let's double click him. We'll notice that our mask is selected, but it's got RGB alpha on, and we want to select the red channel because that's the selection we want to change here. And then now we can alter this pass separately, which is in this case our glass. And that's as simple as it gets with kind of changing the kind of colors using the multi-matte IDs, and these only work with the multi-matte IDs. We never use wire colors or anything like that within Nuke. It's not kind of like a bodge job in Photoshop. You have to get your IDs working properly and make sure you're rendering out lots of different multi-matte IDs for the ones you need. Because Nuke works with the RGB. There are ways that we can kind of key light certain colors and manually make a mask, but this is kind of the best way to do it. It's just with selecting the mask here. So again, let's do that with another element here. Let's select our green for this one. Let's change the color of this, or the intensity of this element. you can see here. And what we'll do is we'll tend to kind of organize our structure, so we're kind of like calling this, if we put another backdrop here, and we'll call this, you know, adjustments or whatever, same as you would do with Photoshop. Say again, sorry? See how the mask looks? There's a question in the... okay, if we... there's a question to kind of see how the mask looks, like what the... you know, kind of like alpha or kind of like visually what it looks like from the audience here. And there is. You wouldn't really need to for stuff like this, but you can.
It's more multiple colors and multiple just to be quick testing without using the correct channel.
Let's just see, because I'll be going through slightly later on, shuffling out channels and creating alpha channels and things like that. But let's just see if we can kind of illustrate this, obviously, in this instance. Again, because you can see literally what this is here, you wouldn't really need to go to see it in an alpha, because you're not really creating an alpha here. You can use alphas as the mask. You can kind of manually create, rather than choosing a red, blue, or green, you can choose RGB alpha, and then that'll pick up a black and white image that you pump in here, which is set as an alpha. So let's do an example of that now quickly while it's being talked about. If we click on this and press shuffle, Shuffle node will take a while to get used to the concept for this node, but essentially what you're doing is you're shuffling out a color or an alpha, and you're doing something else with it. So you can shuffle out an alpha to be an RGB, you can shuffle out an RGB to be an alpha. And these are like really powerful things that I use all the time. Again, in this instance, you wouldn't need to do this here, and we'll try and find a better example later on. But if we double click this, we uncheck our GBA, and we're just left with our A, then we can take the input 1, which is our RGB, and put it in the output to alpha, right? So now if we click on this, we can see our RGB, because up here we've got our RGB selected in our viewer. If we stick on A, which is alpha, you can also see that this is alphaed out, right? So you've got an RGB, we've also got an alpha. Now if I deactivate this shuffle node, my alpha is solid, right? So we've turned the RGB into an alpha, which is super useful. And that's essentially how you create alphas from RGBs or RGBs from alpha, which is exactly using these settings here, basically. So input and output. So we're taking the RGB red only, and we're making that an alpha. And you can take if we just change this, you can change this to green or whatever, or you can change it to just the alpha and shuffle the alpha to RGB. But this has got no alpha data baked within this, so we're just changing the red to RGB. And we need to go back to RGB here, because otherwise, if we accidentally leave it on RGB and click on grade, we can't see anything here because there's no alpha in our scene. So you have to go back to RGB. So this grade node now, we've still selected red because even in our shuffle, our RGB is still red. But we have the option now to check RGB alpha. And it gives us the same results because we've got an alpha linked to our red channel of our RGB. Does that answer your question? Because you can see your alpha within the alpha setting here. You can basically see what your alpha is doing by selecting alpha here.
But I want to see on my grade because I can use the mix on the grade, so I want to see how much the alpha is.
If we just wait for the mic to kind of like get some clarification.
Sorry, it might be my old school workflow, but I do like to see how my mask looks in black and white and gray terms. So when you're having a mask on your grade, you're using the potentially mix to adjust how much it affects, how much effect the grade has.
How much it's affecting the grade?
I just want to see how my mask looks, basically. Maybe it's just an old school. And
I'm slightly confused by the question with that, to be honest, because you can see the effect of that mask is controlled within your grade node. You know, how strong you alter your object, you're adjusting the strength of what you're doing. You don't really want to play around too much with this mix effect because you want to control 100% values of what you're doing in here. If you don't want it to be so blue, then you just turn down the blue. You wouldn't really change the mix amount here, and you can see your alpha of that effect, you know, here. So I'm slightly confused about exactly what you mean and how it translates to other.
It's simple. It's a way to turn up and down an effect of the grade. It's a way that I use quite often to just simply adjust the amount of the white towards black. And it's a way to control, I just make an exaggerated node, and then I simply control the amount that it affects by just adjusting the amount, the alpha.
And how does that differ from the mix amount here?
It doesn't, but I just want to see it. It's maybe my old school workflow. Let's not get hung up into it.
Yeah, I guess I'm slightly confused by, I guess why, yeah, exactly what you mean by that, I guess. Because you can see what your alpha is doing, and then you can control the mix amount here. But again, I wouldn't recommend using the mix amount too much because you want to control the individual settings and what's happening within the grade node here, for example. Were there any other questions online, Jeff? Because I haven't been looking online. You've been away for a while.
It says, when I export an image from Max as a 16-bit EXR and open it in Photoshop, it always looks flat, and Photoshop treats it as a 32-bit. He wants to know why that's happening. And then can you show me the correct settings to have a 16-bit EXR from 3ds Max?
When you're saving your images, you know, you save it as an EXR. I always have the overwriter 1, that's just a habit. But if your gamma is set to output 1, then that'll automatically happen when you have it automatic. But as a force of habit, I output my EXR the gamma of 1, which is what you should do. And then when you then press setup or save, you get your half float 16-bit channel RGBA, and that's all you need to do when saving out your EXRs. And then if we go into Photoshop and we bring in one of these EXRs, bring in an RGB, transparency or alpha, let's load it as an alpha for now. It comes in as it should do because I've saved it as an output of 1. It's not going to come in brighter or darker than your render in Max, and it will be 32-bit channel, right? So you can then, you know, your exposure and everything is going to work correctly because it's in 32-bit mode. You can see the amount of data that's in this file. So as long as you're outputting as 1 from your EXRs and you're saving out as 16-bit 16-bit half float, then you shouldn't get any problems, basically. No other questions? Cool. Okay, so let's back to this. Were there any other questions with the adjustments or anything that I've done with the Nuke by anyone in the class here? Cool. So this is a kind of basic build we've made for a completely 3D scene. And before we kind of go into kind of building a slightly more complex tree with our footage in the other scene, we'll just look at a really cool plugin for Max and Nuke called Nukem, and it just allows Max and Nuke to talk to each other in a really nice way. So what we'll do actually in Nuke, within the same comp, we'll read in our animation that we rendered out. Let's just grab those frames from our static scene. Bring in our RGB. So we can see now we've just brought in our clip for 100 frames. And just to illustrate exactly what we can do with our Nuke and how it works. There's lots of ways you can get data from Max into Nuke, but you know it works with FBX and it works with other file formats. But the one I like to use, because it saves me a bit of time rebuilding the script, is the Nuke script here. So if I first get my scene ready, because I want to I'll add a plane in, I'll add some geometry that I want to export from Max. So I'll add a card. That's what you typically do. You want to kind of put a card or an image or an effect or some smoke. That's got a pre-rendered bit of smoke on a separate card into your scene. So we'll plonk him here behind these spheres. Let's just make sure we've got a, I don't think we've got a RGB for, we don't have a path for our spheres separately, but we can illustrate this using the first mat ID that we have from the still image. So let's just create this plane. We'll create another one nearer the camera. So what we'll do is activate our Nuke, and it brings up this new window. It's very simple to use. Select your camera. We've only got one camera. Select your objects. We'll select our two planes that we've just created. Set our output path. Let's go to our Nuke folder. Within Nuke, we'll create a new folder called Nuke. Press OK. And then there's a few important checkboxes to remember. We do want to output our script, obviously. We want to. We don't really want to show the Nuke script because it just gives you a message within the viewport here. We want to output our chan files. In this case, we don't care about our shaders or our environment or anything like that. We just want the script and the chan files and the geo, the geometry, and it will automatically do whatever the camera's doing with the animation. So it will create keyframes for the animation and translate that data. But we can also select a custom frame range here. And if we have geometry that's moving, we can select geometry sequence, and we can make sure we're creating keyframes for our geometry as well. So we can export everything. So let's press Nuke, see what happens. Instant. Sometimes it's not instant, especially on TRA30, for example, which was the street scene for Jonah. That camera had keyframes on every single frame because it was generated from the tracked camera, and it can take a long time to export the animated camera, basically. The geometry is very fast to export, but sometimes the animated camera can take a little bit of time. So if you've got a complex scene and you're trying this, just be patient. It will work until it exports. So in Nuke, just go in full screen mode. Let's just zoom in a little bit. Now, you don't read this in because it's a script. You have to import it. So let's go to File, Import Script. Let's locate that one there. Nuke, and then you can see it's created kind of folders for my geo, my plane 2 and 3, and it's got a Nuke script here, which is whatever my max file is saved at, static scene. Let's open that. And what it does, it brings in this neat little script, which you could build manually very simply, but it's just nice to not have to. And then what this is essentially our geo files, which is loading OBJs. So if we double click on this, you can see you can see the settings here, where the file is located. We can change that, swap that out, whatever. We have our plane files, which is our Nuke node nodes that will be reading our geos and position data. So that has the translated position data for where things should be. And we can change and edit the curves of how these things are, specifically for things of animation like the camera, for example. Now, so that's our geo file, read geo, position of where that should be, and then our scene, which is just a standard node. It's not specific to anything. If we created a new scene, we could use that instead of that. This is no connection or link to Max. And then we have our V-Ray camera here, which if we double click, again, has animation data and is located in a certain position. All of that is kind of plugging through a scanline render, because you have to essentially translate this position and 3D data into a static image at some point. So it has a kind of scanline render where it kind of translates this relative to the camera, which is why the camera is linked to the scanline render within the objects within our scene. And then that gets pumped through to a scanline render. So let's have a little look at how we kind of attach this to our file. So say this is our flattened thing that we've exported, like here. We can then add a merge node. So we use the merge node for almost every kind of operation which applies two things together. However, we don't want to put it on plus, because we're not rebuilding an RGB. We're not kind of adding this data together in a kind of merged way. We're kind of just applying one on top of the other. So if we add our B channel again to our RGB up there, and we put our A channel to our scanline render, we put 1 on that, we can see that our scene is kind of like doing this. The reason why is because our background, because we didn't export our background, it has no reference on what size this should be, basically. So we can easily sort that out by putting our own background in, or rather our own environment, sorry. Hang on 1 second, or rather a we could use a, let me just check 1 second. Let's go back to Nuke, rather Max, and just check our, let's try and exporting that again with our environment selected and just seeing which node it's exporting there to create our kind of reference to what size this should be. So let's export our chan again. Select our objects, which is our two planes. Output path, it's the same. Let's just export that again. And Nuke, let's just import that script. See what we've done this time is we've got the script with our render output size. So it didn't give me the option to type that in manually, which is a bit annoying. But that's what we want, is our render output size. And then it's linking to this node here, which is our format of 1920 by 1080. So if we plug this in now with our A channel, see what's happening there. We've got the 1920 footage, but our actual render sequence that we've rendered out is only 1024. So we can do two things. Because we're rendering out at 1920 from our scanline render, we could use, just for the illustration purposes of this tutorial, we could use our RGB here of 1920. So that makes it the right size. But if we want to kind of continue this tutorial with our animated sequence here, then we can just reformat this to be the format that we rendered our animation in, which is 1024 by 576. So we can select from one of the options here, and if it's not there, if I can't find it, then we can edit a new one or add a new one here. And we can set the resolution to 1024 by 576. Call this low HD. Now you can see that we've kind of correctly got the right format. What we also need to do is add a Pre-Mult node. And we want to kind of get rid of this background color because we don't want to kind of screen on top of our image without any kind of background. We just want to set the render output size to our default format there. We could have also, instead of reformatted this, changed it here and added our new one here. It just depends on what your kind of scene sizes is and what your render output versus your output here. The size of these things, the format and size makes very little difference to, well, no difference in fact, the quality of what you're working with. It's just whatever format you're creating. So here we've got our cards exported in our scene, and you can see that it's going to be animated with our scene here. Because we're using the kind of camera and we're rendering out scanline from our exported camera. So we can now go ahead and add any kind of maps to this with any kind of it can be an animated graphic exported from After Effects. And that's kind of like the way we use After Effects now, is just to kind of generate motion graphics, and then we do all of our comp within Nuke. So we don't actually comp within After Effects anymore. We just generate any kind of graphic content which needs to be made. So yeah, these are kind of default JPEG maps that have been generated through our export from Nuke. But we can swap this out with any kind of image we want to put on there. Or it doesn't have to be an image, it can be a smoke map. If you wanted to have smoke coming out of this area here, we can kind of do that. And we did that a lot for some of the comps within Jonah. Specifically TRA 30 in the scene, still playing. Specifically in the areas where some of the kind of particle systems are coming out of the walls. Let's have a look. So you see, if we watch this again, when we come out of the wall here, our girl sign that we created, we've got a large amount of kind of dust and smoke that are kind of flying out of here. And these were just cards that were positioned in Max and then brought into Nuke in the exactly same way that I'm teaching you now. And then instead of the kind of default Max texture, we had lots of different smoke textures that were kind of and kind of dust and particles that were kind of purchased through the Andrew Kramer Action Essentials set. So this is essentially how you do that. You don't have to kind of render particles and do really complicated things to add lots of effects. You can use Nuke and you can use all your cards to kind of build complex scenes and setups. So we would have just had lots of different cards on different kind of planes, creating that kind of voluminous kind of effect, basically. So it takes a little bit of time getting used to exactly what this kind of scene setup is. But once you get going, you can create very, very complicated exports and scene setups using multiple cards, with hundreds of these things kind of attached to scene nodes, and just the way that you kind of organize them in ways that work for you visually. And you notice again this little arrow on the side, you can just keep adding more. It's not limited by any number of these things you might want to add on. And then you can manually move these things once they're in there, just by changing the position data within some of these nodes. But essentially it's better just to get that composition right in Max first, and then just use this to kind of connect the textures to. So again, you'll probably add this to a backdrop node, and you'd have this as a separate kind of element to our main tree. But this is why it's kind of called, tree building, because you don't just build one thing down. You're kind of adding to a central spine through these different armatures that kind of come off when you're adding different things. So you can see here we're kind of adding this here. We might have another export with different cards. You know, so we want to put a TV there or a kind of animated screen on these kind of lines there. We might do that. We might have that as a separate kind of element. So if we just kind of move this over slightly and copy this, we might have another merge node kind of leading in from the A channel here. Again, the B channel going through the top. And then we've kind of adding armatures to our tree with different things. And this applies to different renders that we might render out. So this is kind of like, this might be our background footage at the top. And then this might be render 1, which is our fish bar. This might be render 2, with all the different passes rebuilt in a similar way in here. And we're constantly adding things to our comp. Basically, that's kind of the basics on how it works. So were there any questions on this one before I move on to comping the fish bar into the scene of the TRA-30?
There's a question online here. It says, can you elaborate more on saving out EXR files, especially the global options column? Does the compression and storage type affect composition efficiency and speed?
Yes. So if we save a version of this out, let's just save it to the desktop, call this 01, EXR override 1. If we press this, go to our settings, let's just save out the version that I was talking about as version 1. Let's save out version 2, override 1. Let's put this on full 32-bit float with a compression of none. And see what the difference is. So let's have a look. Okay, 01 is 5 megabytes. 02 is 31.6 megabytes. So if you're saving out massive files like that in animation, you're going to have a hard time keeping that composite light. You know, that is a significantly different file size. But if we kind of drag these into Photoshop, let's just close a few of the other files. You know, you've got this EXR2, which with no compression, I don't even know, because we don't really ever do this. Is this what he was talking about, it rendering white when he rendered out full EXRs? Maybe. I mean, that clearly shows just you shouldn't be ever using the full 32-bit float, because Photoshop doesn't work in 32-bit float. Photoshop only works in a kind of half-measured 32-bit. That file should, he says, and confidently, because I'm not really that experienced in using full float, but if we kind of read that image into Nuke, Nuke should be able to read it, because Nuke is full 32-bit float native. Let's have a look if it does or not. This is new to me too, to be honest, because there's no way I'd ever read just like looking at the desktop. Let's just have a quick look. If we go to users desktop. Let's just click and drag him in. You can click and drag any of our assets into Nuke as well, and it's the same thing as doing reading files. So even in Nuke, he doesn't like that that second EXR file. That's why I never render out full 32-bit. You can see it there. If you select it within Max, you can read it, so it is there, but programs just don't like that file format. Let's have a look again. Yeah, it's just I don't have much experience with using it, because I've always noticed the file sizes were too big. If we put the scanline compression back on this. There we go. Sorry, I selected the wrong full float. I just went to 32-bit. So if we try that again, let's have a look if Photoshop reads it. So no compression. Yeah, so make sure that's on full float, not integer. Save over that. So let's have a look again. Because Nuke definitely can read full 32-bit files, as you can see here. But let's look at the file size difference. Again, our second one is 31.6 megabytes, and it doesn't really make that much difference, in my opinion, to the depth that you're getting. Let's have a look and see if there's any range difference with the exposure. I mean, again, there seems to be no benefit for me with rendering out full 32-bit float. It seems to be a very similar effect and a very similar depth. I can't see why you would ever need to really render out a full 32-bit float, and you can just see the file size difference. Can you ask him if that answers this question, or if he was asking something slightly more specific? Okay. Well, hopefully that answers your kind of question. Just making sure that you save out your images override of 1 and then half float EXR. Got a follow-up. RGBA, half float, 16-bit.
So you said that's good, but how about storage type, tiles or scanline?
I've never changed this. So I don't know, basically. I've always left it as the default, which I think is tiles.
One reads faster, and I don't know which.
Okay, apparently one reads faster, and it should be the default one, I'd imagine. So, but yeah. I normally leave this on default here, and just have this on 16-bit half float RGBA. So let's go back into Nuke. So what I'm going to do is I'm going to kind of open up a separate file, which should be the kind of beginnings of the comp for the street scene. And we'll look at some of our kind of standard templates that we use for compositing, and also how kind of some of this stuff was made. So if we go into our tree, you can see the kind of the way we've built this, and there's lots of things we would change if we were to do this again. And again, every comp gets slightly more optimized and slightly more kind of ordered, and as your workflow changes. We've got an example of our current workflow. Everything about this is made in exactly the same principles as we've been showing. It's just that we've got a slightly more organized in the way that we group some of our nodes, basically. So if we go over to our kind of setup here, we can see we've got our read files. This is just for our fish bar. So you can see our this is our footage. So we've got all of our read files on the top, with all of our different kind of passes. And then we have our base set up for our tree, which has our background footage at the top. Whatever kind of grade nodes and color correction we want to kind of do. Jeff, can you get me some water, please? And our kind of base RGB, and this is kind of our template that we use for all of our kind of comps for all of our different elements. So you can see here, there's just a place for everything. There's a place for rebuilding our RGB. There's a little box to put our raw baked RGB. There's our kind of color correction. If we're adding kind of Z depth effects with the kind of fog, which is also then linked to our depth of field. We have a kind of alpha setup, and I'll talk about that as well in a second. And then we have any kind of individual chromatic abrasion effects that we are applying to our model. And then we have our light wrap effect, and I'll try and explain that a little bit, which has less of effect on this scene in particular for this comp, but will be explained a lot more when we look at the more of the character stuff inside the fish later on this afternoon. And then we have our kind of main roto feed, which is designed to kind of be pumped through lots of different nodes if it needs to be. And then our kind of render shadow using our matte shadow and any AO effects that we might be using. So we'll start with this and we'll see where we get to, and then in about 10 minutes we'll break for lunch and we'll continue it afterwards. So again, the first thing we want to do is rebuild our RGB. So let's kind of go through this together, and let's kind of create this comp and see how it's working with our footage, and we'll try and grade it into the scene. So let's first create some postage stamps. And let's just copy these in. Let's make sure that we're hiding the input. So we can select them all and try and link them quickly. So let's get the ones we need. So we need the V-Ray lighting, we need the global illumination. That's the raw lighting, so don't make that mistake. We don't need the raw lighting, we need the V-Ray lighting to rebuild our RGB. V-Ray reflection. We need our refraction, we need our specular. Any others that we need here? Don't need our shadows. You thought you would, but you don't. And then we have our RGB and alpha. We need our alpha as well later on. I'll explain how the kind of alpha system works, particularly in this scene, which was done a little bit differently to how I'm going to show you this afternoon for the cart and how the kind of cart was rendered into that other passing shot. So let's just take these for now and try and rebuild our RGB. We don't have a background or anything like that. We didn't need that. Let's see if we've got our passes we need. So put our alpha there for now, within our alpha folder. We'll explain that in a second. Let's just start rebuilding some of this stuff. Not too sure what that is yet, so we'll just leave them inactivated. Sometimes I'll leave the multiply nodes in, just so I can kind of, don't have to add them in later and I want to change some of the passes like we did earlier. So let's just have a quick look. Let's bring our RGB in and see what we've done. So we've got our render of our fish bar there, our RGB. So there's a slight difference there, apart from the fact that we've got our background in 1, which is fine. Let's just double check some of our nodes. So yeah, we should have all the ones we need. you will find sometimes, specifically with, depending on how your glass and refraction settings are, you know the Vray setting for affect all in your refraction and your reflection. This can affect how your refraction rebuilds, because if you're affecting all in your glass materials, then you will essentially be kind of baking in that refraction to all of your other passes, and that will affect how your kind of RGB rebuilds. So sometimes you kind of don't want to have that option checked, even though you want to affect the alpha. So if you just affect the color only or just affect the alpha, that's fine. But if you select all channels, just be aware that in your glass you're going to be affecting more than you realize. So we have a specular, refraction, reflection, lighting, and global illumination. That should be all we need, which is what we have. So this is already kind of alphaed out, and we can see our alpha here. If we go to our A channel, we can see that this is kind of what our alpha is affecting. But the reason why it's kind of so thick is because we have essentially, let's just put that back on F8. We've essentially kind of doubled up our alpha however many times we've got our passes. So we've got 1, 2, 3, 4, 5. 5 times that our kind of ultra contribution of our image is kind of like multiplying on top. So you kind of see here that this is our RGB alpha, and this is our rebuilt RGB alpha. And that's because we're kind of, yeah, like I said, we're multiplying that kind of transparency effect of our edges of our model that we're kind of having our contact shadows on 5 times. And we need to kind of combat that down here in our alpha setting here. So we've rebuilt it. We can do whatever color correction we want. We'll just disable that for now. We can load in our Z depth to kind of play around with different grading techniques for the kind of the background. But we'll leave that there unlinked for now. And just talk about this alpha channel here. Let's just disable this. So let's just make this window smaller, or this window bigger. So if we leave our alpha on for illustration purposes and see what we're doing here, what we need to do is we need to use a copy node. And what we need to do with that copy node is we need to essentially shuffle out the RGB to alpha of this image here, if it doesn't have an alpha channel. So if we click on our alpha, it is actually got an alpha channel. But if we've accidentally saved our animation as RGB rather than RGBA, we've still got our alpha channel as a kind of image. So we'd be able to use the shuffle node like we did before and shuffling out the kind of RGBA to alpha, basically. And we'd be able to kind of create an alpha if we didn't have one already. So if we kind of click on our copy node, we're essentially copying the alpha from here and we're applying it to everything that's above our B node here. And then we're using our pre-mult, which kind of like pre-multiply that process, which is a little bit of a weird concept. So you can see here that if we put our 2 channel there, so our 2 is before this alpha and our 1 is after, so we're going 1 and 2, you can see that we're neutralizing that multiplication of the alpha effect of our passes, and by using 1 reference point for our alpha should be. So hopefully everyone's with me there. So we have this within our alpha box here, so we know exactly what's going on. Again, the Nuke is so good because we can have a non-destructive approach to everything. If we turn back to our RGB, we can kind of create chromatic abrasion effects, all kind of live within the comp here, so we're not having to go through separate plugins or programs like other kind of workflows. And it's all kind of within very obviously labeled sections here, and that's just by shuffling out the red from the RGBA and then moving that a little bit to create that kind of effect, basically. So again, you'll use the shuffle and the shuffle copy node in different ways, and it's just getting used to exactly what you can do with them and what processes are used for that. So for example, shuffle copy, again, it's the same as our dude here, but the difference is that we're selecting what channels to kind of use. We're kind of using this as the transform, and we're affecting everything from here upwards, basically. That's what that's saying. So that kind of illustrates kind of our standard workflow for creating a kind of working with a kind of rendered exported element or animation. And before we go any further, let's break for lunch. Now we've explained this process, or let's take questions on this, and then we'll break for lunch, and we'll be back later on to explain more. So with this process that we've set up here, which is our standard kind of workflow for creating comps, or the beginning of comps. So were there any questions in the class or online before we break? Well, let's break for lunch then.